This beautiful type of graph is going to be the subject of our new unit, and this graph is called a parabola, and the equation is a quadratic equation. We know it's a quadratic equation because the largest exponent is 2, or it's degree 2, and the parabola has this beautiful shape. As we go through this unit, you may be using this form, the items to learn form. If you are watching this for class, then we're going to be focusing on some of the items in this part of the items to learn form. And by the end of the film, or the end of this short video, you would have run across all of these terms and installed them into your brain. Let's begin with the vertex. In this case, the vertex has the coordinates 1, -9. The vertex is the tip of your parabola, and it's not scaled on the y-axis, but the coordinates here are 1, -9. And in this case, my vertex is a minimum, meaning it's a low point on the graph. If my parabola happened to be shaped like this, opening downward, the vertex would be a maximum because it's a high point on the graph. Minimum low point on the graph, maximum high point on the graph, and the vertex is the tip of the graph. So we've talked about the maximum and minimum. Let's now talk about the axis of symmetry. If you take a look at this graph, you can kind of see that it is very symmetric, meaning what's happening on the right side is happening on the left side. Or you could also envision it this way. There's kind of a center line that goes right through the center of your graph, allowing you to have a mirror image of this side of this side. Think of that axis of symmetry as the spine of your graph, and in this case, the equation of that axis of symmetry is the equation of the line x equals 1, because that axis of symmetry goes through the point x equals 1 on the x-axis. Another example of the axis of symmetry, we've drawn a new parabola over here. There's the vertex, it's opening downward. The spine, or the center of this parabola, is this line, x equals -2. I know the equation because this vertical line goes through the spot on the x-axis of -2. We're now going to take a look at the roots of the equation. The roots of the equation can also be called the x-intercepts. So use those two terms interchangeably, roots and x-intercepts. So here I have an x-intercept of 4, 0. Here I have an intercept of -2, 0. So in our case, the roots are x equals 4 and x equals -2. Or you could call the roots 4, 0 and -2, 0. These roots are going to come back and be big shot stars later on in this chapter. Let's now focus on what's called standard form, and what should go through your mind is exponents are in descending order, but let's take a look at what that means. This equation, this quadratic equation, represents this graph. This equation is already in standard form because I go from an exponent of 2 to an exponent of 1, we don't write it, but it's there, to no exponent at all. So my exponents are in descending order. This is the same equation rearranged, but now the exponents are not in descending order, so I would say not standard form, even though it's still a legal equation. This thing, same reason, the exponents are not in descending order, so I can't call that standard form. And this, believe it or not, is also the same thing as this, it's just in factored form, but it's not in standard form. So we're going to care about standard form because it's going to make your life easier later in the unit. So standard form, descending exponents, and then you have standard form. We're going to end the video by thinking about how to find function values. So here's the equation that we're working with. There it is up there. And I'm going to rewrite it into function form, and this is going to allow us to plug in x values and get out y values. So let's say I was making a table, I wanted to plug in a 4, and I wonder what y value I'm going to get out. That means just f of 4. I'm plugging in 4 to the equation up above. You've done this many times in your algebra career. And we get 0. That means when I plug in a 4, I get out a 0, or the ordered pair 4, 0, which makes sense because if I were to plot the ordered pair 4, 0, it lands right on my graph. Any x value that I plug into any x value that I plug into this equation will get out a y value, and that combination of x and y will end up being a point on that graph. When you watch the video on Desmos, or you already know this actually, you'll find out how Desmos can help you evaluate function values by creating a table on Desmos. That way you don't have to do the math. That's the show, so hopefully now you're familiar with the vocabulary and the anatomy of a beautiful parabola or quadratic equation.